I think we can start. So, hello everyone. Welcome to the next meetup organized jointly by quantum computing groups from Washington, D.C., Toronto, and Warsaw. My name is Pavel. I'm the moderator today. The second moderator, Sebastian, will probably join us later, and I know that Helen will also help in moderating the event because I will need to leave soon after the start, after the beginning. Before we start, let me introduce our great guest, great speaker, Professor Sneha Lada, and she will give a talk about the Agentic AI Masterclass for leaders, managers, and founders. So I hope that you'll find it very interesting. The title sounds great. Before we proceed, I would also like to announce our next events, next meetups. So next week, on Sunday as well, Dr. Jarek Duda from Jagiellonian University will give a talk about potential applications of negative radiation pressure in astronomy, medicine, and two-way quantum computing. So perhaps some of you can remember that we've already had one talk about this two-way quantum computing. It was given by Jarek several months ago. And then in May, um, I'll be actually one of the speakers as well, but I also try to moderate and together with my colleagues from Europe, with Dragos from Romania and Moritz Cartier-van Diesel, who's now a PhD candidate in Graz in Austria. We'll tell you about the Pain-Vita model of urban traffic networks in the presence of traffic lights and its application to traffic optimization. So it's not related to quantum computing, at least not directly, because I know that there are also some quantum approaches to tackle the traffic signal control problem. But in this talk in May, we'll tell you about some classical approaches, but using machine learning as well. Okay, and I see that there will be also another talk on that day given by Terry Bollinger about an easy intro to Feynman's QAD, part two, adding alternative histories. Then in June, Dr. Yan Junji, who is a postdoctoral researcher at the Jülich Supercomputing Center, will tell about machine learning for reliable quantum computing and algorithm hardware co-design perspective. And then in June, part three of the lectures given by Terry about an introduction to Feynman's QAD, electron-photon interactions this time. In July, Vijay Krishna will tell us about the quantum observer problem towards self-aware decision systems in a complex world. It's July 12th. And 1 week later, there will be a Q&A on physics and AI with Terry again. So Terry will be quite busy during our meetups in the next couple of months. And later in July, Dr. Bruna Gabrieli from Purdue University will tell us about compactifying the electronic wave function to quantum estimators for spin-coupled generalized valence bond wave functions. And then in August, on August 1st, Dr. Javier Ordust will tell about the mathematical foundations for modern cryptography in the quantum era, and I'll be one of the moderators. And then in September, Dragos Manea, again, our guest from Romania, will tell about a mesh-free numerical method for Dirichlet eigenpairs in the Laplacian with potential. And then there will be some next meetups this year, but they will be announced later. So with this, I will stop sharing my slides. And yeah, Dr. Snehal, if you are ready, the Zoom is yours. So first of all, thank you for accepting our invitation. It's our pleasure to have you with us today. And we are looking forward to your talk. And maybe just one quick announcement to our participants. We've agreed with the professor that if you have any questions, you can post your questions on the chat, and there will be a dedicated Q&A session at the end I believe that Helen will moderate it or Sebastian. So Professor will answer questions at the end. Thank you and enjoy the lecture.
Thank you so much, Pavel. I just wanted to confirm, is my screen visible and I'm audible?
Yes, I can hear you and I can see your screen.
Thank you so much for confirming. So, hello and welcome to today's session. We are going to talk about something which is rapidly changing: how business operate via agentic AI. Now, most of the people think that AI is just like a tool, like a chatbot or automation. But today, we are stepping beyond that into AI systems that can think, decide, and act autonomously to achieve business goals. If you are a founder, manager, or leader, it is not just a technology shift, it is a leadership shift. In this session, I'll show you how agentic AI can help you automate decision making, streamline operations, and build intelligent systems that work alongside your teams. We'll cover what agentic AI really is, how is being used in real businesses, and how you can start implementing it without needing a technical background. And it is purely no code session.
Professor, just a quick question because one of our participants has just mentioned that we can still see a small screen with my names. So perhaps there should be another screen sharing option on Zoom when you can. Okay, oh now it's better. Okay, good.
Oh, yeah? Okay. All right,
Thanks.
sure. So, before we begin, I'd like to ask how many of you are already using AI in your businesses in some or other form? You can drop a quick yes or no in the chat box, or we can discuss this in the question and answer session later. So I think all of us, we have used chatbots like ChatGPT, Gemini for some or other purposes. But now, how we can use agentic AI for businesses, today we're going to discuss that. So let's see how much of your team's time is spent on repetitive and operational tasks, responding to routine emails, following up with the leads, updating system and reports, handling common customer queries. In most of the organization, this accounts for a significant portion of daily work. This challenge is not that this work is unimportant. It is that it consumes time that could be better spent on many other things like strategic thinking, decision making, and business growth. So, in other words, highly skilled people are often engaged in low leverage activities. This is where the current wave of AI presents a very practical opportunity, not just in terms of productivity, but how we can design and operate our businesses effectively. So, AI did not suddenly become powerful overnight. It has evolved through clear stages. In early days, we had rule based systems, software that followed predefined instructions. The systems were predictable but rigid and limited. Then came machine learning, where systems learn patterns from data. This improved accuracy but still required humans to define goals and workflow. Next, we entered into the era of generative AI, where systems like ChatGPT could generate text, image, and codes. The systems are excellent at responding, but they still wait for instructions. Now we are entering into the era of agentic AI. Agentic AI systems don't just respond, they can set goals, plan steps, use tools, take actions, observe outcomes, and improve over time. This shift is important because it changes AI from a tool to a digital worker. For leaders, this means AI is no longer just supporting work, it is beginning to execute workflows. And that changes everything. What makes agentic AI truly different is a fundamental shift in how AI behaves. So, first, AI is moving from responding to acting. Traditional AI systems wait for prompts and provide outputs. Agentic AI can take initiative, deciding what actions are needed to achieve a certain goal. Second, AI is shifting from tools to autonomous systems. Earlier, AI tools supported human work. Agentic AI systems operate with a level of independence, using tools, making decisions, and adapting to changing conditions. Third, AI is evolving from task assistance to workflow execution. So instead of helping with the isolated task, AI agents can manage end to end processes, coordinating steps, handling exceptions, and delivering outcomes. For leaders, this shift matters because it changes AI from something that supports work to something that executes work. Understanding this transformation is essential for making informed decisions about productivity, risk, and governance in AI agent era. So as we have discussed that AI has transformed from responding to acting. Let's take an example of customer support. Earlier, AI chatbot answer customer questions and waits for the customer to ask. Now, in case of agentic AI, an AI agent detects a delivery delay, proactively notifies the customer, issues a refund or a discount, and updates the CRM system automatically. So the AI doesn't wait to be asked, here it acts. Second transition is from tools to autonomous systems. Here we'll discuss an example of finance and reporting, how AI can be used in finance and reporting. Earlier, in earlier AI, tools help to analyze and generate reports, but humans still trigger, compile, and review everything. In case of agentic AI, an AI agent pulls the financial data, validates the inconsistencies, generate reports, flag if there are any anomalies, and escalates issues to the leadership automatically. The system operates as an autonomous unit and not as a tool. Third transition is from task assistance to workflow. Here we'll take an example of HR hiring process. So earlier AI helped to screen resumes or draft interview questions. But now with agentic AI, we can have AI agents which screens the resume, schedule interviews, coordinate feedback, send offer letter, and hands off approved candidate to onboarding. The agent executes the entire workflow end to end. So for leaders, this shift means AI is no longer just improving efficiency, it is reshaping how works get done. So what basically is agentic AI? Agentic AI refers to AI systems that are goal driven and autonomous. Instead of being told every step, the systems are given an objective and they decide how to achieve that objective. So, first, agentic AI systems are goal driven. You define the outcome, not the instructions. The agent focuses on achieving that goal. Second, they are capable of planning. AI agents can break a complex goal into smaller steps, decide the order of actions, and adjust the plan if any condition changes. Third, agentic AI systems can take actions using tools. They can search the web, access documents, update systems, send messages, or interact with software also, just like a digital worker. So finally, they are able to learn from outcomes. So by observing result and feedback, AI agents can improve future decisions and actions over time. When these capabilities come together, AI moves beyond assistance. So agentic AI is AI that can autonomously act. So, for leaders, this definition is important because it signals a shift from AI as a tool to AI as an active participant in business workflows. Now, let's talk about agents, chatbots, and co pilots. Many people use these terms, chatbots, co pilots, and AI agents, interchangeably, but they are very different from each other. Chatbots respond to questions. They wait for input, provide answers, and they do not plan or act. While co-pilot assist human while they work. They improve productivity but still depend on continuous human direction. Now the AI agents are goal-driven systems. You give them an objective, they decide how to achieve it using tools, making decisions, and taking actions. So, from leadership perspective, this distinction matters because only AI agents can automate entire workflow and not just individual tasks. So, we'll take an example of AI business analyst using Google Gemini. We'll see a demonstration of it. So, for this, what I have done, I have got this spreadsheet of businesses where different columns are there. That is basically a data set of different salesperson, region, products which they are selling, and the customer type, how many leads they have got, how many leads are converted, what is the revenue, cost, discount, and target. So this is the data, and this is the summary of the data. So, based on the name of the salesperson and how much total revenue is generated by each of the salesperson and how much is the total profit. And this is the dashboard where it shows metric and the values. How much is the total revenue, total cost, total profit, and achievement. So, what we're going to do here, this is a very basic, simple example I'm taking to show how Google Gemini can be used as a business analyst. So this data I have downloaded as an Excel file, and now I'm going to open Google Gemini. So as you open Google Gemini, this sheet I have uploaded, and then the important task is to give proper prompts. I have asked Gemini to analyze this data set and give the top performing salesperson and best and worst products. So look at to the analysis performed by Gemini. So it gives top performing salesman with the lead conversion, how much is the total profit, what is the key strength, what are the best and worst products as per the prompt mentioned. So you get analysis of the data set completely here. And then also you can see what is the revenue trend, what are the unusual patterns about different products, region wise struggle, customer type variance, and efficiency gap. So now after that, another prompt which I have given is to think, ask Gemini to think and act like a business analyst. So I have given a prompt to act as a senior business analyst. So from this data set, identify key problems in the sales performance and then analyze the profitability. That is revenue versus cost. So look at to the way as I have given prompt to this Gemini to act, not just to give, not just to assist me. Look at to the analysis given by Gemini, where it mentions what are the key problems in the sales performance, profitability analysis of each product, impact of discount, actionable strategies for growth. So all of that is generated by Gemini because I've asked it to act as a business analyst based on the given data set. Next prompt I have given to Gemini that you are a AI business agent. Identify underperforming salesperson, flag cases where revenue is less than 70% of target, suggest specific action for each issue. So here, human intervention is there. We are giving prompts to Gemini to analyze the data and then provide the results based on that. So based on data, it shows underperforming salesperson region wise. What is the target? Specific action plan. How this revenue can be improved. So for each salesperson, what is the issue? For Michael's issue, that is the conversion gap was identified, and then what action can be taken, and what is the expected outcome. So for each salesperson and product-wise analysis also is performed here, which mentions what are the assigned action and what are the expected outcomes after achieving this. Also, management alert message is also scheduled. So where we schedule a message to the management that uh, some salesperson are not meeting the targets and some products are not performing well, and this is the recommendation. So this is how the complete this is the analysis given by Gemini as we asked Gemini to act as AI business agent. Next prompt I have given is to act as an intelligent HR recruiter manager. So this is the second task that we are going to do later. So I wanted to give you idea about how Gemini can be used for businesses to analyze any data and then give outcome and insight of the data to improve the outcome. So that was about the first demo where we talked about AI business analyst using Google Gemini, where this is no code and automated thinking was involved. So why leaders must care now? So leaders must care because AI is no longer just supporting work. It is beginning to execute work. So when AI systems move from answering questions to making decisions and taking actions, the impact goes beyond technology. It affects how teams operate, how processes scale, and how accountability is managed. Organizations that understand and adopt AI agents early gain speed, efficiency, and strategic advantage. Those that wait risk failing behind, not because they lack the technology, but because they delay leadership decisions. This is why agentic AI is not an IT topic, but a boardroom and leadership topic. So, when leaders think about AI agents, the first question is not what technology to use, because there are a number of tools available these days in market, and we all are confused which one is good for a particular task, which to use, how to use, because we cannot have hands on all of the tools which are available. So, the first question is where AI agent is actually going to create a value. This means identifying repetitive, time consuming, or decision heavy workflows where speed, consistency, and scale matters more than the human judgment. Second, focus is the level of autonomy that is acceptable for decision making, because now we are involving AI to take decision on our behalf. So how much autonomous the system should be, that is also very important. So, not every process should be fully autonomous. Some agents may only recommend actions, while others may execute tasks with human approval. Autonomy should always be deliberate, a leadership choice and not an accident. Third focus is how humans remain in control. Effective agentic AI systems include clear human in the loop mechanism, escalation paths, and the ability to override or stop an agent when needed. Autonomy must never mean loss of accountability. Finally, leaders must define how success and risk are measured. Success is not just about automation, it is about time saved, errors reduced, decision improved, and risk managed. AI leaders at the same time, leaders must monitor bias, failures, and unintended outcomes. So, when leaders focus on these four areas, AI agents become a strategic advantage, not a source of uncertainty. So, now as all of us know what agentic AI is, it is basically an autonomous system which is used to create workflows where autonomy can be controlled. Let's talk about how these AI agents act and think. So, before AI agents can act, they must think. Understanding how AI agents reason is important, not to build them, but to trust, govern, and guide them as leaders. So, what is AI reasoning basically? It is the ability of system to think before it acts. So that is a human nature. We also think before we act. So that capability we want to have in our AI systems also, in our AI agents also. It starts with understanding the goal, what exactly the objective, and what outcome is expected. Next, the system thinks through possible steps. It considers different options, evaluates constraints, and identifies potential paths to reach the certain goal. Then it chooses the next best action. So, not just any action, but the one that is logically moves it closer to the objective. And finally, reflects on the results. So, did the action work? Does it need any adjustment? Should it try? Should we try a different approach? So, reasoning is not a random output generation. It is a structured thinking before action. And that structured thinking is what makes AI agents intelligent than reactive. Let's begin by understanding why reasoning actually changes in AI system. Most AI systems can generate responses. They take an input, produces an output. But reasoning introduces something far more powerful: decision making. A chatbot might simply answer a question, but an AI agent, on the other hand, evaluate the context before acting. For example, imagine you have a meeting at 2 p.m. A chatbot will say you have a meeting at 2 p.m. But if we use AI agent for this, it will check the traffic conditions, estimate travel time, and after evaluating these parameters, agent will say traffic is heavy, you should leave by 1:15 p.m. This is the difference. Reasoning allows system to understand the context, evaluate options, and select the best next action. It moves the AI from reacting to thinking, and that shift is foundational for building true agents. Reasoning enables complex goal handling. Let's talk about complexity. Real world goals are rarely single step. They involve constraints, trade off, and multiple decisions. Suppose a user says plan a 3-day trip under 40,000. This is not a simple information query. AI, if we are using AI agents, agent must search and compare flights, check hotel prices, allocate budget properly, and adjust options if total cost exceeds the limit, which requires structured reasoning. The agent must break a large goal into smaller subtasks, evaluate each task, and then continuously adjust. So, without reasoning, the system could only provide general travel suggestions. But with reasoning, it can strategize and optimize. This is what enables autonomy. AI agent is not just responding, it is working towards an objective. Now let's talk about reasoning, which makes AI explainable and auditable. Let's look at the trust. In domains like healthcare, finance, or legal systems, AI decisions cannot be black boxes. If an AI agent approves a loan, flags a medical scam, or rejects or an insurance claim, we must understand why. So reasoning enables transparency. It allows systems to show what criteria were evaluated, what thresholds were applied, what logic path was followed. For example, a loan approval decision may include income above a required threshold, debt to income ratio within limit, credit score above cutoff. So when reasoning steps are available, decision becomes explainable, and explainability builds trust. And trust is essential when deploying AI agents in real world environments. Without reasoning, we get outputs. With reasoning, we get accountable decisions. So that's why reasoning is important in building AI agent systems. Now we'll talk about chain of thought reasoning. So this is often called COT. Chain of thought simply means step by step thinking. So instead of jumping directly to answer, the AI breaks the problem into smaller logical steps and works through them sequentially. It is similar to how we solve the maths problem. We don't just write the answer, we show our working step by step. This is exactly what is chain of thought and how it works. So by thinking step by step, the system makes decision explainable. We can see how it moves from question to conclusion. This is especially powerful in complex tasks like multitask step planning, logical reasoning, or numerical problems. Because the reasoning path is explicit, errors are reduced. The model is less likely to skip steps or make incorrect assumptions. So, so think of chain of thought as a structured reasoning made visible. It is not just about getting the right answer, it's about showing how the answer was derived. So, let's understand chain of thought reasoning through a business example. Imagine we are performing financial analysis and the goal is simple, identify cost overruns. So now instead of jumping directly to conclusions, the agents follow the reasoning flow. First, it reviews the expenses categories: marketing, operations, salaries, strategy, logistics, and so on. Next, it compares each category against the approved budget. Then it identifies anomalies, areas where spending significantly exceeds projections. Finally, it flags. Then it identifies anomalies, and then finally it flags the potential risks for leadership, highlighting which overrun could impact the profitability or quarterly targets. So notice what happened here. The system didn't just say that the costs are high, it followed a structured reasoning path: review, compare, detect, and escalate. So, this step by step flow is called as chain of thought reasoning in action. It makes analysis transparent, logical, and easier for decision makers to trust. Next is react reasoning, which is reason and act. Here, AI agent doesn't just think, it alternates between reasoning and taking action. It reasons about what to do next, takes an action using a tool, observes the outcome, and then update its plan. This loop allows agents to operate in real changing environment. So in React, from task assistance to workflow execution. Let's discuss example of React reasoning where it is a flow from task assistance to workflow execution. So here we'll be discussing an example of HR hiring process. Let's look at the shift from simple task assistance to full workflow execution using HR hiring process. Earlier, AI systems were assistive. They could screen resume based on keywords. They could draft interview questions. They helped with individual tasks, but they did not manage the entire process. Now let's look how agentic AI can do this. Here, an AI agent doesn't just assist in resume scrutiny, it executes. It screens the resume based on predefined criteria, automatically schedules interview based on availability. It collects and coordinate interview feedback and generate an offer, send offer letters also. And once the candidate accepts the offer letter, it hands off the approved candidate to the onboarding team. So notice the difference here. So this is no longer a task level support. This is a complete end-to-end workflow execution. So agent understands the goal, hiring the right candidate, and the manages every step required to achieve this outcome. That's the power of agentic system. They don't just help human to work, they complete the structure workflow autonomously. We'll take an example, one more example of customer support agent here. Let's understand React using customer support example. The goal is simple here is to resolve the customer issue. Now, instead of giving generic response to all the customers, AI agent follow a React loop: reason and act. So first it reasons about the problem. So what is the issue? Is it delayed order or a payment failure or a damaged product? What is the reason behind the complaint? Next, it acts by checking the order status in the system. Based on the information, it takes corrective action. Maybe initiating a refund, reshipping the product, or escalating the case. Then it updates the customer with a clear explanation of what was done. Finally, it verifies resolution, ensuring the issue is truly solved. This is React in action: reason, act, observe, and adjust. Not just answering the customer, but actively solving the problem. As we have discussed what chain of thought and react is, let's have a comparison of both of these reasoning approaches. Both are powerful, but they are used in different situations. Chain of thought is structured thinking before action. The system thinks through the entire problem step by step and then produces the final answer. It is best suited for analysis. Things like financial evaluation, logical reasoning, complex calculations. So it is mostly static reasoning. Think first and then act. While React combines reasoning and action in an iterative loop. The system thinks, take action, observe the result, and then adjust the next step accordingly. It is not a static process, but a dynamic one. It is ideal for real world tasks, customer support, workflow, execution, troubleshooting. So, this is dynamic reasoning where thinking and acting is continuously involved. So, in simple terms, chain of thought is deliberate analysis, while React is interactive problem solving. Understanding when to use each is the key to build any effective AI agent system. So, let's talk about why leaders must care about reasoning in AI agent system. First, reasoning improves the trust, which is first and foremost important thing. When AI systems can explain how they arrive to a decision, leaders feel more confident deploying them in the critical process. Transparency builds the credibility. Second, reasoning enables control. So, if you can see the logic path, you can audit it, refine it, and align it with the organizational policies. So, you are not just accepting output, but you are governing the decision making process using agents. Third is reasoning reduces the risk also. So, structured thinking minimizes random or inconsistent behavior. It reduces costly mistakes, compliance failures, and reputational damage. So, here is the key takeaway: better reasoning leads to better outcomes. So, not just smarter AI, but a safer decision, stronger governance, and more reliable business impact. So, for leaders, founders, and managers, reasoning is not a technical task, it is not a technical detail, it is a strategic advantage. So, as we have now seen what is agentic AI, so agents are involved. So, how agent must think and act via reasoning. So, we have discussed chain of thoughts and react through different examples also. Now, we'll discuss planning and goal decomposition. These are core capabilities of intelligent agents. So, instead of trying to solve a big problem all at once, the agent first understands the overall objective. Then it breaks that objective into smaller, manageable subtasks. Each subtask becomes a step in a structured plan. For example, if the goal is to launch a product, agent must decompose into market research, budgeting, marketing strategy, and execution tracking. So this approach reduces the complexity. It makes the large goals actionable. So, planning answers the question: what sequence of steps will achieve the goal? Goal decomposition answers what smaller tasks must be completed first. Together, they transform ambition into execution. So, let's understand why planning is critical in AI agents. First, planning converts goals into structured actions. A goal is just an intention. Planning turns that intention into clear sequence of steps. Secondly, planning helps handle complexity and uncertainty. Real world environments are dynamic, constraints changes, information evolves. A well structured plan allows to agent to adapt without losing direction. Third, Planning enables autonomy without chaos. Autonomous systems must make decisions independently, but without a structured plan, those decisions can become inconsistent, inefficient, or even risky. So, without planning, autonomy becomes risk, and planning is what ensures intelligent agent act deliberately, but not randomly. So, planning involves goal decomposition, right? Now, let's see what is goal decomposition. It is the process of taking high level objective and breaking it into smaller, manageable sub goals. It starts with clear understanding of overall objective. Then the agent divides that objective into smaller subtasks, which are easier to execute. Next, it decides the sequence and the priority, which task should be done first, and then which depends on others. Finally, it executes step by step, moving steadily towards the final outcome. So think of it how manager assigns the work. A CEO sets a big goal like launching a new product. Managers break that goal into marketing, operations, finance, and logistic tasks. Each team handles its part in a structured order. This is goal decomposition in action. And in AI agents, this capability turns big ambitions into achievable workflows. Consider a sales leader who set a goal to increase the quarterly sales. AI agent here doesn't jump straight into sending email. It first analyzes the customer data, identifies high potential leads, prioritizes accounts, recommend outreach strategies, and then track outcomes, adjusting the plan as needed. So this is planning in action. We'll take one more example of operation efficiency. So in operations, a leader may want to reduce delay. In AI agent, an AI agent breaks this down by identifying the bottlenecks, analyzing the root causes, suggesting improvements, and monitoring the results over time. Instead of firefighting, leaders get structured problem solving. Next comes dynamic planning. So, planning is not static. And in intelligent system, plans are not fixed once created, they evolve. As new information comes in, agent adjust their plans based on the feedback. If conditions change, a deadline shifts, a resource becomes unavailable, a new data appears, the agent reprioritizes. It may modify steps, change the sequence, or even redefine the sub goals. This creates a continuous improvement loop. So think of it as a dynamic planning where the steps are plan, act, observe, adjust, and continue. The key idea is simple. Planning is not just a one time activity. It is an ongoing process that keeps agent aligned with its goal even in changing environment. So as we discussed, planning and goal decomposition. So for planning, AI agent requires memory. So for AI agent to act intelligently over time, they need memory. Memory allows AI agent to remember the context, learn from the experience, and avoid repeating mistakes, just like humans do. So why memory matters here? Memory is essential for intelligent agents because we are trying to implement a system where agents are involved which thinks and act like human. So memory is an important component. It enables the continuity. The agent remembers past interactions decision instead of starting from scratch. It prevents repeated mistakes by learning from previous outcomes. Also, over time, it improves decision quality by recognizing patterns and refining actions. So, the key insight is that without memory, autonomy has no learning. So, AI, an agent may act but not evolve if memory is not involved. Now, what are the different types of memory in AI agents? So, there are basically three types: short term, long term, and vector memory. So they use different kinds of memory for different needs. Short term for immediate context, long term for perseverance, and vector memory for intelligent retrieval. So let's talk about these memories in details. So short term memory. It allows agent to remember what is happening right now. It stores current conversation, active task details, and immediate context. This memory only lasts for a session. We all have experienced some kind of short memory when we talk to chatbots. Every time you refresh it, you will have a new conversation. So that is a short term memory. So this memory only lasts for a session. Once the interaction ends, the context may be cleared. It is similar to human working memory, like remembering a phone number just enough to dial it. For example, during an ongoing discussion or task execution, agent remembers previous instruction so it can respond consistently. So short-term memory keeps interaction coherent and focused. Let's take an example of meeting assistance. So during the meeting, it remembers the agenda. So discussion stay aligned with objectives. It tracks the key discussion points as participants speak. It identifies discussion made and generates generate action items in real time. But once the meeting ends, the session specific context can be cleared. This is a short term memory in action, focused, temporary, and task driven. It supports execution in the moment without storing everything permanently. Then comes long term memory. It stores the persistent information. Unlike the short term memory, it does not disappear after a session ends. It retains preferences, rules, historic data, and past decisions. This allows agent to maintain continuity across interactions and improve over time. For example, it may remember company policies, users' communication preferences, or previous strategic decisions. So, because of long term memory, the agent doesn't act, it learns. And that learning strengthens the future decision making. We'll try to correlate it with one of the example as an HR or operation agent. So it remembers the company policies, hiring rules, leave structure, approval hierarchies, and over the time it takes approval patterns, which requests are typically accepted, which ones require escalation. It gathers more experiences, it adapts its recommendations, and it may pre-flag a high risk request or fast track routine approvals. This is a long term memory in action. Here, doesn't just follow rules, it evolves based on the history. Next comes vector memory. It stores information based on meaning and not the exact text. Instead of matching keywords, it requires semantic similarity. This enables semantic search. The agents can retrieve relevant information even if wording is different. For example, A query about reducing expenses can retrieve documents about cost optimization also. So if even if the exact phrase doesn't match, so think of it as search by meaning. So vector memory allows agent AI agents to recall information intelligently, making them for more flexible and context aware. We'll see that as an example of knowledge and research agent. So here the goal is to quickly extract meaningful insights from a large volume of internal documents. The first AI agent searches internal reports, policies, research papers, or meeting transcripts. So after performing research, it doesn't just search by keywords. It uses the vector memory. It retrieves information based on meaning, even if wording is different. It identifies most relevant insight from those documents, and finally it summarizes the key information in concise, decision ready format. So, this is the vector memory in action, not just searching data, but understanding the retrieving knowledge intelligently. So, each memory type plays a different role. Together, they allow AI agent to be context aware, consistent, and intelligent. Let's look at to the one of the most common problems in business. So here, that is the lead comes in, but not all the leads are valuable. Some are serious, some are just exploring, some will never convert. Yet most businesses treat all the leads same. So this creates two major issues. Time is wasted on low quality leads, and high quality leads are not responded quickly. So the speed is everything in sales that we know. What if every lead was automatically analyzed, categorized as hot, warm, cold, and responded instantly without manual effort? So that's what we are going to build now. So let me just show you how we're going to create this AI lead qualification system. So it will basically capture lead, uses AI to qualify, spends personalized reply automatically, and then for creating this AI lead qualification system, these are some prerequisites. So for this session, I have already made this setting available. So Google Form, Google Sheet, Gmail account, and Zapier account. So these are the requirements. So I'm going to show you a quick demo of AI lead qualification using Zapier. So this is what I was talking about. Building uh, um, AI automation system which analyzes lead and sends the personalized email responses. So to send email responses, we require email account to be linked. Also, we to collect lead, we need some form. So for that, what I have done, I have created a simple lead form. So you can put that on your website, or you can connect it with your chatbots, whatever you have. I'll give you a short example of this website, which is Intellexus AI, which does AI automation, which provide different AI automation strategies. So for this website, this is a simple form: name, last name, email, and message. Right? What is the query? So we have got this lead form generated and integrated to the website. So name, email, message, and budget. So now we need to integrate this form to the AI agent so that responses are collected analysis is performed, and then action is also taken in the form of sending emails. So let's see what I have done here. So this is the Zapier account of mine where I have created this Zap. Zap is just a workflow. So this is my AI lead analysis workflow, which sends the personalized email also. So here what I have done, I have taken a trigger. So first important thing is trigger. So from where input is coming, right? So here input is coming from Google Forms, that is which is capturing the leads. And then that Google Form is linked to Google Sheets, so where we basically store our data set. And then that sheet, Google Sheet, is attached to Zapier. So this is what is Google Sheet. So this Google Sheet is a trigger. As soon as I'm just clicking on this, so that you can see what are the different parameters what you see here. So when you click on this says it is a lead form and it collects the responses. Then second is, let's just quickly click on this. Yeah. So if you double click on this, you can see the setup. So here you just have to select the app as Google Sheet and then trigger the event, select it as new or updated spreadsheet, because as somebody enters into the Google form, that get added into the sheet, so that every lead comes into the sheet, that has to be updated. So that is taken as a trigger event. So as something is entered into the sheet, trigger is generated. And then I have taken this account. You have to pair your Gmail account with this, and then after doing setup, next is configuring. So you have to select the particular Google Sheet. This is what a Google Sheet I have created. It's very simple, only 2 responses I've taken. So these are the different columns like email, name, email, message, and budget, right? So so you have to take that sheet which is here, responses, form responses one. So that's what is selected here, form responses one. And then you can test it, right? So you can continue with the selected record also. So next thing is action. So here you add AI agent that you want. So here we are going to select AI by Zapier. So you can select it and then select the provider, this OpenAI, and it uses the Zapier AI credits. You can select the model also, which model you want. I have selected this GPT 4o mini model, and then you have to give a prompt, which is very important here, because we want this automation to act as a sales assistant. So I've given a prompt here that you are a sales assistant, analyze this lead and analyze all the columns. So in each column, we have different entries like name, email, requirement, and budget. So I have asked this agent to act as a sales assistant and analyze the lead form and then classify this as hot, warm, or cold, because I want to know which one is more important so that I can respond to those hot leads first. And then give short reason and write a personalized email reply. And for email, whatever you want to mention, what name you want to write, best regards, your company name, whatever you want to write, you can modify this. And then this is the output format where you can get to see classification, reason, and email. So these are some basic settings that you'll have to do, and these are very simple. Anybody can do that. After this, next is filter. So for this, again, click on it and select filter by Zapier. And then you can configure and test here. And after analyzing, so we have taken an input from Google Sheet, we have used AI agent by Zapier, we have applied a filter, and then next is to take action. So we have connected Gmail account here, so that email will be sent from my Gmail ID to all the leads which are there in the Excel sheet. So here I have linked my Gmail account, and action event is to send an email. So I want this system to automatically send email to all the leads which are there in the Google form, and then select the account, configure it. Some basic settings are there. So here, on which there are different columns, right? You can see here what are the different columns. So C, D, E. E is the message, right? And D is the email ID, and C is the name of the person, for example. So to whom to send email, we have selected column D. What should be the subject? So we have selected column E. So column E is the message. So based on their requirement, we are sending an email, right? So that comes into column E. So we have written a short prompt, you could say. So that is the subject. We can help you with column E needs, whatever are the requirements, we can help you with that. And then what will the body of this email? So hi, column C is the name of the person, and then the output, that is the classification, that we have identified your lead, and then based on that we are doing this classification and send email. So you can definitely modify this, and these are some basic settings that you'll have to do, and then continue. So that was it. So I will run this test. So you can see here test run started successfully. So all of these workflows are getting executed one by one, and then you can see the Zap run is successful, and then you can check the email ID also, from which on which the email was sent. You can I think I forgot to log in, and oh yeah. So yeah, you can check. So based on the entries which are there in the email ID section, the emails are particularly emails are sent. Let me just. Alright, so yeah, it works in a very simple way, where AI agents does the complete task of getting the leads, and then analyzing the leads, and then classification is done based on in different categories, hot, cold, and warm, and then emails are sent accordingly. So that is how we can build an AI agent for a lead qualification. That is the complete system which captures the lead, uses AI to qualify, and sends the personalized replies also. So once you build this agent on Zapier, you don't have to rebuild it. So whenever the lead comes, it automatically sends email. So this is the simple workflow I have taken for this session. Let me quickly go back to where we were. So I hope there are many tools available. So I have taken Zapier. There are many tools like N8N. N8N is also AI workflow automation tool, but there you have to manually select all the tools that you want in your workflow. There are some workflows also. You can select those based on your requirement. You can modify it, and Zapier is comparatively easy than an 8n. So yeah, so what we discussed about memory here. So memory is not a technical feature, it's a governance and the trust mechanism. It is well designed. Memory makes AI agents more predictable, adjustable, and auditable and valuable. All right. So next topic we're going to discuss is tool usage and API calling. So yeah, so far we have seen how agents think, plan, and remember. But reasoning alone is not enough. AI agents become truly powerful when they can use tools and interact with systems. This is what allows them to take real world action. So why tools matter? So tool usage is what enables real world action. An AI system may be intelligent, but without tools, it remains limited to generating responses. So what we have seen, right? Just collecting input from Google Sheet and generating responses, that is sending emails. That was a very simple example. But then tools connect AI to actual business systems, databases, CRMs, HR platforms, financial softwares, APIs, and more. So through these connections, agent can retrieve live data, update records, trigger workflows, and automate decisions. So this is what turns intelligence into execution. So without tools, AI can think, but it cannot act. So what are the tools for AI agents? Tools are mechanism which allows agent to interact with the real world, right? So like Google Sheets we have taken, forms we have integrated. So these are some of the tools, right? And then they include business applications like HR system. You already have your HR system, CRMs. You can integrate those also with the AI agent. Existing platforms can also be integrated. They include databases, internal documents where information is stored. It also includes communication platform, email, calendars, CRMs, where coordination happens. And they include APIs and internal systems that power business operations. So in simple terms, tools are the ways an AI agent take action. So without tools, the agent can generate ideas. With tools, it executes the outcome. So when we're talking about tools and API, so what is API calling? APIs allow system to talk to each other. So they act as a bridge between different software platforms. AI agent use APIs to perform action like retrieving data, updating records. For example, I want to have a research AI agent which will do research on weather, and then based on the weather reports, it will generate a forecast. So for this I would require an API key which will track the real time updates of the weather. So it can retrieve the data, update the record, triggering the workflows or sending notifications, and all of this can happen without human intervention. So just think of APIs as digital handshake between systems. They allow the agent to communicate, coordinate, and execute tasks seamlessly across multiple platforms. Without API, systems remain isolated, and with API, intelligent automation becomes possible. Let's take an example of sales agent. Consider a sales follow-up agent. It checks CRM data, sends personalized email, update the leads status, and schedule meetings automatically. So these are the roles of this sales follow-up agent. This is not assistance, it is execution, end-to-end execution. Another example, finance and reporting. So in finance, AI agent can connect directly to accounting system through API. It can pull the real-time financial data, generate performance reports, analyze spending patterns automatically. It can detect anomalies such as unusual expenses or budget overruns, and it can immediately flag them. It can even notify leadership with a structured summary of the issue. All of this happens without manual intervention. And the result, that is the improved speed, higher accuracy, and stronger oversight. That's the power of intelligent automation connected to business systems. One more example we'll take that is about operations. So an AI agent uses tool to actively manage workflows. First, it monitors the workflow in real time, tracking task progress, delays, and system performance. If it detects an issue, it triggers alert automatically. It updates the dashboard with the latest operational data, so leaders can have you can have a live visibility, and when necessary, it escalates the issue to appropriate team or a decision maker. Look at the difference here. So AI agent here is not just analyzing operations, is actively managing and coordinating them. So that's tool enable execution in action. So I think you all know now how AI agents can be used in different workflows to build automation from scratch and use APIs and existing softwares which can also be integrated. All right. Now we'll talk about automation and control. Give me a second. Yeah, autonomy and control. So let's talk about it. Here's the key question to ask: who decides the agent, what agent can do? Answer is simply you, leaders, managers, right? So permissions are defined at the organizational level. You decide what systems the agent can access, what actions it can take, and where escalation is required. Agents operate within a clear defined boundaries. They are autonomous, but only within the scope you configure them. And human always remain in control. So autonomy is not unlimited freedom. It is configurable intelligence. So when designed properly, agents can act independently but never outside the governance. Now we'll talk about feedback loops and self improvements. Let's talk about it. How do AI agents get better over time? So it starts with execution. Agents take action, complete a task, makes a recommendation, triggers the workflow, and then comes the feedback. What was the outcome? Was the outcome successful? Did the action achieve the intended goal? Were there any errors or inefficiencies? So that feedback is analyzed and incorporated into future decisions. Over the time, the agent adjusts strategies, refine priorities, and improves performance. So the journey is simple, from execution to evaluation and improvement. So this continuous loop is what transforms automation into learning. And learning is what makes autonomy smarter over time. We'll take an example of executive decision support agent. Imagine a leadership team using AI agent to support strategic decisions. Initially, agent reviews the market data, trends, competitors, competitor movements, financial indicators. Then it summarizes risk and opportunities. Then it recommends strategic options, for example, expansion, cost optimization, or product repositioning. Now comes the feedback loop. Leaders, you either approve or reject the recommendations. So, over the time, the actual outcomes of those decisions are tracked. Did the revenue improve? Did risk materialize? Did strategy succeed? This feedback is critical. The agent begin to learn which type of recommendations are typically accepted. It adapts how it frames risk and trade-offs. So future recommendations become more aligned with the leadership preferences and decision pattern. And this is how it works for leaders. AI improves the judgment quality, not just the speed. Learning is driven by leadership feedback, not random data. And most importantly, accountability remains human with human. Agent supports and leaders decide. Another example is about compliance and policy monitoring agent. So imagine an AI agent continuously monitoring internal processes for regulatory and policy compliances. Initially, the agent reviews transaction and activities across systems. If it detects any pattern that violate the internal policies and operation activities, regulatory standards, it flag potential compliance issue. Now comes the feedback loop. The compliance team reviews these flags. They confirm the valid risk, identify false positives, and note any missed issues. This validation is critical. So over the time, agent learns which patterns truly indicate the risk. It reduces the false alarm over time. It improves the detection accuracy and it begins to focus attention on genuinely high risk cases. So now here is why this works for the management. It demonstrates a risk reduction, not just operational efficiency. Feedback strengthens the trust in the system, and most importantly, it aligns directly with the governance, compliance, and audit policies priorities. The AI enhances the oversight, but accountability remains with the team. Now, as we have talked about AI agents and different components of AI agents, we'll see what are the different types of AI agents. So, when we talk about different types, because not all the agents are same. Some are simple and reactive, others are goal driven, planning and reasoning before acting, more advanced. Yeah. So, some are complex, some are simple. Some simple are those which underperforms, and if it is too complex, it introduces avoidable risks also. So the right match of agent is very important because it creates value. So this slide basically compares three common AI agent architecture: simple agent, multi-agent, and hierarchical agents. So single agent, there is the one agent, one goal, and one workflow. It is basic and focused, and it is ideal for well-defined tasks with low complexity. Next is multi-agent systems. Multiple agents collaborate towards a shared goal. Each agent may specialize in different functions, making the model more flexible and suitable for complex problems. And finally, the hierarchical agent systems. This mirrors how organization works. A manager agent supervises worker agents and assign the task and consolidate results. It provides structure, control, and scalability. So, in simple terms, single agent is basic and focused, multi agent is collaborative, and hierarchical is controlled and scalable. The right architecture depends on complexity, risk, and governance needs. So now that we know single agents is only about one agent, one goal, and one decision loop is there. This agent is focused and the well-defined tasks are there. Let's look at the example of single agent system where I have taken executive research agent. So this agent has clearly one goal, which supports the leadership with relevant and timely intelligence, which continuously monitors the market trends, competitors' activities, industry developments, and then analyzes information, filters out the noise, and then summarizes only the key insights. And finally, it delivers the structured briefing directly to the company, saving time and improving clarity. So there is no collaboration with other agents, no layered supervision. There is only one agent, and this is how a simple but powerful agentic AI can deliver immediate strategic value. Next is multi-agent. So there are multiple agents work together towards a shared and the coordinated goal. Here we will take an example of strategy analysis system. So where the different agents are involved here, which works together for a single goal. So on the screen you can see there are three agents: research agent, because we want to do strategy analysis, build strategy analysis system. So research agent, and then a analysis agent, and synthetic synthesis agent. So multiple agents collaborate towards a shared strategic goal. So research agent gathers the relevant data, analysis agent evaluate options, identifies patterns, and assess the risk and the trade-off. And synthesis agent consolidates everything into structured recommendation for leadership. So for each agent performs independently, that is a specified role, but objective is shared. So this is where multi-agent systems shine, breaking down complex strategy challenges into coordinated, intelligent collaboration. Next is hierarchical agents, which is a manager-worker model. So here, a manager agent defines the goal and sets the direction. Worker agent executes their task and send results back to the manager. Manager evaluates the output, checks the alignment with the objective, and adjusts the instructions if needed. So here the structure is simple. Control flows downward from manager to worker, and feedback flows upward from worker to manager. So this model mirrors how organization work. It provides structure autonomy, better alignment, and scalable coordination. Let's take an example of hierarchical agent model where we'll discuss market expansion strategy. So imagine a team is deciding whether to enter a new market or not. So instead of endless meetings and scattered reports, a manager agent defines the evaluation criteria: growth potential, competition, regulation, financial returns. So this is so then it deploys specialized agents. One analyzes the demand trends and customer segments. Another studies the competitor positioning and pricing. Third evaluates the regulatory risks. Each agent works independently but under structured command, and the result flows upward. Manager validates the findings, refines the analysis, and delivers the consolidated. recommendation to the leadership. So this is how hierarchical agent system works. Next comes a swarm agents. So the most decentralized form of AI collaboration. Instead of central manager controlling the system, many autonomous agents interact locally with each other. So each agent follows simple rules, but through continuous interaction, collective intelligence emerges here in this case. So this concept is inspired by nature and colonies, finding optimal path, bird flocking together, bees coordinating complex tasks without a leader. So swarm systems are particularly effective for large scale optimization and adaptive environments where centralized control may become inefficient. And these agents offer powerful scalability, but they require careful governance and to ensure the system stays aligned with the organizational goals. This is how swarm agent works. So, first, the agent observe the environment, gather local information, and sensing the signals from their surrounding. Then they follow up simple rules which guide their behavior and decision taking at a local level. Then agent interact with nearby agents, sharing signals, exchanging information. This interaction allows the swarm to coordinate without any central controller. And based on this interaction, agents adapt using feedback, adjusting their behaviors and improving their responses over time. As this process continues, collective intelligence begins to emerge, where patterns form and swarm starts working together efficiently. Finally, the system converges towards optimized solution, such as finding the best route, allocating resources, or solving complex organization problems. And this is the power of swarm intelligence, simple agents working together to create powerful outcomes. And the last one is human in the loop agent. So here humans are involved to strengthen the AI with human judgment. So in this model, AI agent analyzes data and generates recommendation. However, instead of acting autonomously, the decision is reviewed by human. The human can approve, modify, reject the AI's recommendation before any action is taken. This approach is particularly important in high impact environments such as healthcare, finance, compliance, strategic decision making. So, human in the loop system allow organizations to benefit from AI speed and intelligence while maintaining oversight, accountability, and trust. So, this is how human in the loop system agent works, where human is involved and decision is taken by human, involving human in the loop to take decisions, and then actions are executed. So, so choosing the right AI agent architecture is very important because there are different AI agent architectures which are suitable for different types of problems. Single agent system, multi-agent, hierarchical, and swarm intelligent are designed for a specific tasks. So, selection of these AI agents is an important thing for leaders, founders, and managers for their organization. So the key is not just to adapt AI agents, but selecting the right architecture for the problem you want to solve. So choosing the right tool is very important. So this is what these are the different tools which are available and which are most commonly used for automation. And it and make Zapier for multi-agent collaboration, AutoGen and Crew AI, building AI applications, LangChain, visual prototyping, Flowise, and long-running agents, LangGraph, enterprise AI integration, semantic kernels are used, and private data AI, Llama Index. These are the different tools which are available. So selection of tools is very important. So finally, the framework like semantic kernel are designed for integrating AI and enterprise level scheme. And the key is not choosing every tool, but selecting the right one for your organization's use case and technical maturity. So with this, I end this talk on agentic AI for leaders, managers, and founders. Hello. Hello, Helen.
Yes. Yes.
Yeah, so I'm done with this today's talk. I hope everybody liked this talk on agentic AI for uh, high level managers, leaders, and to how to have these different tools in their organization for different goals, and how they can set up the workflows and involve AI agents, not just as an assistant, but as a decision maker also.
Maybe it's time for Q&A. For the first question, what was the filter in the Zapier example?
Sorry, what was?
Um, what was the filter in the Zapier example?
Yes, so filter is to select what type of data you want to filter. You can apply different conditions, like in setup I have given like continue, only continue if. So if certain conditions are mentioned, so we can have different filters. Like I have said, classification as hot, warm, and cold. So if you can set the filter on which basis you decide this is a hot lead or cold lead or warm lead.
And the other example is for the email example, does it require feedback from user based on a series of feedback makers, example hardcode lead classification? If it's good or bad, change in email response with change in classifier, or does the agent learn automatically based on the email feedback?
Is it in this chat box? I'll just quickly go through the question.
Yes, it's in the chat box. It's a question earlier. It's from Joshua Aran. He
Okay,
asked the
yeah,
question.
we might get to this, but for learning and adjusting our time for email example, does it require feedback from user? So yeah, that was Joshua. So your question is to involve human in the system or not? Yes. So we have different discussed different agents, right? So single agent, multi-agent, hierarchical, swarm agent, and human in the loop. So you decide based on your organizational goals what type of AI agent and architecture you want, and then you can involve human in the loop of automation so that human can also take the decision.
And the next question is there different models that are better at managing?
The different models that are better at managing. So yeah, there are different models. So basically, you design a model based using different agents. So as we have discussed, based on the requirement of a company, you decide what you want, and then decide what type of agent you want in the system, and then you can have different models also, which are which are better at managing. So I have taken an example of multi agents, right? So research agent, and there are 2 3 agents. You can have a number of agents in your system. So the main task will be divided into sub goals. So each of the agent will perform independently, but then they will collectively fulfill the goal of the company.
And the next question is, what are the privacy considerations and mitigations should leaders be aware of?
So yes, including AI agents in business, it's a risk, trust issue, and governance responsibility, because agentic system act autonomously, then can access, process, and share the data at scale, but increases both impact and risk. So the clear breakdown is key privacy consideration and practical mitigations. So risk are so that's why ethical AI and responsible AI nowadays is very important. So each organization should have their policies and regulations for how AI shall be used in their organization.
And the next question is, do you recommend Google ADK?
So it's not about recommending any tool. So I think you can definitely explore all the tools which are there. So just to give you key insight, because as number of tools are there, right? You can definitely explore all the tools, but then based on this requirement, select a tool and then go ahead with it.
The next question is, what's the biggest governance gap you're seeing in companies deploying agentic AI right now?
Mm, yeah. So governance gap is, companies are deploying AI agents faster than they are defining who is accountable for decision and action. So yeah, that's the biggest governance gap I could see. So why the decision was made and what data was used and what happens if something goes wrong, who is accountable for this. So initially I think agentic AI is not just an advice, it can act autonomously also, but without governance it may lead to privacy violation, biased or incorrect decisions. So yeah, most of the companies still use traditional AI governance, which assumes AI as a passive tool and human as decision maker, like human in the loop system.
Another question is, can I assume you can layer different types of agents, ending with human in the loop to assure the outcomes?
Can assume you can layer different types of agent. Yeah, I think it is the same thing which I have discussed. Like based on the governance policies, you can decide what type of which agents you want in your company, and do you really want human in the loop to take decision to ensure what are the outcomes. Yeah. One more question is there from Kyle. So, are humans able to audit any metrics that agent used to learn and adapt? Yes. So, like, because we are human and we are designing this workflow for our organizations. So, autonomy is very important, right? So, we decide, human decide how much the system should be autonomous. So, definitely humans are able to audit any metrics and then refine and then reframe also. From Terry, there is a question: do you have any collected data on accuracy, reliability, privacy, security of LLM based agentic systems in actual business environments? I have not yet done this research on, all of these parameters. But then, yes, AI is being used everywhere, and uh, AI under the control of human, I think that is the best thing that any organization should have.
The other
What
question is, what happens when automated AI agent don't have API keys or can its tools, maybe can access to its tools?
So if API keys are not available, then the real-time data is not available with you. So you'll be basically working on the data which is previously available. So real world data won't be available if API keys are not involved. So like in the simple workflow, I didn't need any API key to send an email. So it satisfied my goal, right? But when I want to do research on real time data, then integrating AI, APIs are very important, because that is basically handshake between different software tools, so that you don't have to collect the data from scratch. You get a ready-made data.
And I got a feedback from John Kellogg. He said it seems that all levels are simply training agents at different tasks, whether one or as a manager many. At what point it is it really a goal-based agent, except that it was trained to process for a specific goal?
Um, so that agent, just give me a second. I'll go through this question. It seems that.
Maybe John can unmute. Can you unmute yourself and ask a question?
Yeah, I got the question. So, is it really a goal-based agent, except that it was trained to process for a specific goal? So we create these agents to fulfill the goal, whatever is the goal of the organization. Like we have discussed different examples. So lead collection and sending an email, right? So that was the specific goal. So I designed the workflow for that task only. So you can have a number of workflows. You can have different agents based on the requirement.
I see a comment from Terry Bollinger, vector memory. There are the Hilbert space quasi dimensions developed from the training data. DeepSeek shortcut others by predefining them using a small, carefully selected data set.
Oh, these are helper quasi dimension developed from training data.
Terry, do you have a comment or
And
question?
it's kind of, sorry, that it's a deep detail. It was just interesting when she talked about the vector memory. That has
Yeah,
a very specific and extensive literature in the detailed literature. So it's just a little reference to some of the papers from back in the 19 teens. So interesting topic, and it really is the core of how LLM works. So
yeah,
just a comment.
true, true.
For questions, Professor Lads, thank you very much for your presentation. It was an excellent presentation. I had a question similar to question that Terry asked a few minutes ago. Earlier during your presentation, you gave examples of case studies by the AI agents. So I wonder if there were some verification, a correlation between AI case studies with human assessment to see if there were some correlation between the output from the agents and from real human, and also if you are aware of cases where studies were done by the AI, and then there's verification by human, and then a validation with real world and that perhaps would help us to build some kind of confidence on these AI systems.
Yes. So, with reference to this, I would like to say this is not really specific about agentic AI, but the use of AI in real world application. And this was the topic of my PhD, where I used MRI images from radiology department of one of the local institute, and then we collected the images and we performed analysis on liver disease detection. So we used AI models to identify if there is any what do you say the identify tumor and classify it as benign or malignant, and that analysis was performed using different models and classification was done, and the results were validated by the radiologist. And based on the accuracy, I mean, accuracy and everything was pretty good, but then we wanted to validate it by a radiologist, and we did that, and radiologists were happy with the results as they compared, the how they do analysis manually and how I have done using AI.
Yeah, thank you. And now my last question is a bit subjective. What I've been thinking is that the AI may be used in management, but also you mentioned in the recruiting, hiring, etc. And my thought may be too subjective. Is that we humans we are not guided only by logical and reasoning. We are guided to some extent by our emotions. So
Yes.
the emotional side, or some people may call the EQ, play part of management and also in our reasoning. So I wonder if this AI agent may lack this emotional side that humans have, and that may have a different outcome in terms of management or solving some of real issues.
Yes, definitely. I can definitely understand this issue. Having emotional intelligence in machines is not still there. So it is with human, and then if we have human in the loop system, we can definitely, take decisions based on our emotional intelligence rather than pure workflow based thing.
Yeah, thank you. So, yeah, I wondered because if we rely heavily on AI to do interview, young graduates or young people applying for jobs, and the person comes to the interview on a day where he is not in a good mood or something happened emotionally in their life, and AI could automatically reject it based on a very strict logical systems built in. Do you follow me what I mean? So is this kind of thing which concerns me that heavily relying on these systems can have some negative impact.
Yeah, I mean, I totally agree with your point. So that is the battle we are going through, right? So will AI replace humans? So that is the thing, that is a point of discussion everywhere. So yeah, it's pretty much subjective. So based on your organizational policies, governance, what on which basis you want to recruit a person is totally subjective.
Yes, fine. Thank you. Thank you for your replies.
Thank you so much.
I got one more question from Kyle. He said, "Thank you so much, Professor. My last question is: there any data showing the trade-offs between various multiple managerial and swarm AI agents if this variation produce better results under certain cases? For instance, do the managerial need make better choice make better decisions, or if the swan are faster?
Yeah. So research shows that no single agent architecture consistently outperforms other. So hierarchical, which is manager-based system, provide better control and reliability. Swarm systems excel in parallel and high-scale environments, and multi-agents setups outperform single agents only when their task can be, cleanly decomposed. So there is a key trade-off in coordination overhead, what you gain in specialization and scale, and often lose in latency, cost, and complexity. So yes, there is a data, and but there is a show trade-off and not a single best architecture. So performance heavily depends on the task structure, coordination cost, and risk tolerance.
Another question. Currently, we are taking a risk-based approach, so low-risk services can go through the pipeline with a reduced focus. However, the nature of governance in the government space I work in still means bottlenecks. Would be interest on how you are handling it.
Uh, can you tell me the name of the participant because I can't find that question?
It's from Phil. Let me copy and paste his
Yeah,
question.
yeah, that would be better. Yeah.
Yes, I just copy and paste his question.
Done, and currently we are taking risk-based approach. So low risk services can go the pipeline. Stand hard handling it. So yeah, I mean, you're describing exactly the tension most public sectors teams are facing right now. Risk-based governance, but the bottlenecks are there in the practice, especially with the agentic system. So they are not removing governance; they are re-architecting it to be continuous and automated, not front-loaded and manual. There is one more question. Is Zapier free entirely regarding APIs, etc.? Zapier is not free entirely. Some Zaps are free for a few days, like I think 10 days. You can have a number of Zaps. And then there is a premium subscription that you have to buy for Zapier. And I think most of the AI tools, they provide some free workflows, and then after some time or after some workflows you'll have to go for the premium subscription of their apps. And then regarding APIs, yes, API also you'll have to purchase, you'll have to have a domain if or where you can integrate APIs with your system, all the APIs.
And Terry Bollinger says maybe a reduction in human staff. He says several companies have already gone fully into the use of agentic AI while simultaneously reducing human staff. It's worth looking into such examples since they provide a hard-nosed assessment of such success and failures. People worry about the reduction in force if we introduce
Yes,
AI.
yes. So yeah, that is the global question and problem everywhere. So the people with no AI knowledge will be replaced with people having AI knowledge for sure.
And Terry just comment, this is a very good summary of what is going on with the agentic systems these days. Thank you for covering this topic in such an excellent detail.
Thanks so much.
So it seems that we cover all the questions. If you still have some more questions, please feel free to ask.
Just have a comment there to Professor Ladd. You present this today for management. I wonder that similar agents can be applied for industries in engineering, and so I
Yes,
wonder if you've been working for engineering applications.
yes, definitely. For engineering applications, also AI agents can be employed. So there are many use cases where AI agents can be used. Like for research, I have discussed for any kind of research you want to do for, like, say, product engineering, for anything, research agents can be employed. And then for production and different workflows can be created.
Yeah, thank you, because I thought that it would be far more objective than perhaps in management, because the engineering rules might be a bit more stricter, and the application might be much higher in terms of potential. Yeah, thank you.
Thank you.
And I got a question from Kyle. Thanks again, Dr. L. I was wondering if the AI agents make decisions based on decision trees or win probabilities.
Yeah, I'm just going through the question. Oh, I was wondering if AI agents make decisions based on decision trees or win probabilities. So AI agents, modern AI agents don't rely on a single method like decision tree or win probabilities. They are typically a combination of probabilistic reasoning, learn patterns, and structured decision logic. So in most of the enterprise systems, they use hybrid approach, probabilities for reasoning and decision logic for control.
So far, that's all the questions that I see on the chat. Do anyone still have more questions? Yeah, I see good comment. Wonderful presentation. Great presentation. Thank you for the presentation. One more thing from Kyle. Great. Thank you so much. Do you recommend and local places where we can play with them?
Um, so I basically don't recommend any no code, low code. So I have mentioned few of the tools already in my presentation, like Zapier, which is easier starting point. And then there is Make, which is more flexible than Zapier. N8N I have also mentioned, which is best for open source option. So for government and privacy sensitive setups, we can use N8N. Flowwise is also there, and Microsoft Copilot Studio, and there are different simple frameworks which you can definitely have hands on.
How about Gemini? I saw you demo with Gemini.
Yes, Gemini you can also use. So it is basically like LLM. It's like a chatbot. You give something, and it is not like a complete workflow that you can build, but on Google Studio, definitely you can do that. Airtable is also good. Yes, I also like it. Jessica. So I'm also trying to explore all these tools, one by one. So because there are n number of tools, and it becomes difficult to select for what task, and most of them are not free. So yeah, unlimited APIs. There is no such, I think, tool which provides free unlimited APIs. Yeah, you need to buy. Like some of the API providers are there, which is OpenAI and Google. So I have got the subscription of OpenAI where I can access different APIs from it. So data safety is definitely a concern. So because we are linking our, personal, like in this workflow of Zapier, I have linked my personal email ID to it. So definitely they have got access to the data which is there. But then you'll have to decide based on your requirement which tool you prefer.
So are there more questions? Please feel free to unmute and discuss. If there's no more questions, and again, thank you, Dr. Laha, for joining our section. And you're welcome to come back if you want to talk about your PhD research with the MRI image.
Definitely.
Yeah, sure.
I'm looking forward for it.
Yeah, sure. If you are interested to come back, we are open in August, September, October, and so on.
Sure, we'll definitely get back to you.
Sure. And Jessica said, thank you. This was helpful. Yeah, we got a lot of good feedback.
Thank you, Jessica. Thank you, Sam.
So next time we will have Terry and Dr. Duda next week. Again, thank you all coming. See you next week. But by the way, can you send me your slides so that I can forward to the participants?
Yes, definitely. I will
Sure.
send.
Thank you.
Thank
And
you.
again, thank you for
Thank you, everyone. Thank you.
Thank you.